Hey guys, Math with Lamari here, and in today's video, we're going to look at the second of two tricky math problems that I picked out from an SAT exam from the 1980s. I also want to add that we're looking at a geometry problem this time, and I would say this problem is a little bit more involved than the last one. If you didn't watch that video, then I recommend watching that one first, although I suppose it doesn't really matter. But yeah, let's just go over this problem together and see what we can figure out. Just like in the last problem, if you could take some time to pause the video and see if you can think of a solution to this problem, or at least think about a possible approach to a solution, that would be great. I'll give you time to do that. Now, regardless of whether or not you pause the video, we're going to go ahead and review this problem together. It says the following. In the figure above, if O is the center of the circle and the length of side AB of right triangle AOB is 6 square roots of 2, what is the area of the shaded region? Now, just like in the last problem, what we're going to do is make sure we clearly understand what the problem is asking us to find. Here, we want to find the area of the shaded region. The area of what shaded region? This shaded area right here. It's somewhat of a strange shape. We'll talk about that in more detail later on. And the important information we're given is that, well, we have a circle here, and O is the center of the circle, and we're given the side length here, side length AB. We have a right triangle AOB, and essentially, again, we have right triangle that's inside of a circle, and these two details are going to be needed in order to make progress here. Now, going back to the shape of this shaded region, it looks very strange, doesn't it? But we'll have an easier time if we just break this up into maybe shapes that we already know how to find the areas of, or shapes that we're more familiar with, at least. If you look closely, what you have here is a quarter circle, right? But then imagine that you cut out a triangle in a quarter circle. After you cut out this triangle, you'd be left with this shaded area right here, wouldn't you? So that tells us that, we can break this problem down into a couple of steps. And I'm going to write these steps here. All right, so the first step is going to be to find the area of the quarter circle. And a quarter circle is just a fourth of a circle. A quarter circle in this case is just this portion of the circle right here. All right, the second step is going to be finding the area of the triangle, triangle AOB specifically. And then once we have the area of the quarter circle and the area of triangle AOB, our last step is going to be So let's say step 3, we're going to be subtracting those areas. Subtract area of triangle AOB from area of quarter circle. And once we've done these 3 things, we'll have our solution. All right, let's see if I can move this text down here. That's good. Let's start with step 1, which would be finding the area of this quarter circle. If you remember from maybe algebra or geometry, the area of a circle is pi r squared. I'll use a marker to write this. But this will be for an entire circle, right? Like I mentioned, we want the area of a quarter circle or a fourth of a circle. So what formula do you think we would use to find an area of a quarter circle? Well, if you guessed 1/4 pi r squared, you'd be correct. We're just going to do 1/4 pi r squared. Let's say this is area of quarter circle. Let's see if I can move this in a bit. It's getting a little messy. Okay. Apologies for that. Alright. Yeah, so again, area of a quarter circle is 1/4 pi r squared, where r is the radius of the circle. But now that we've gone over this formula, we've now exposed a different issue here, which is that we don't know what the radius of the circle is. So before continuing with step 1, we actually need to take a little bit of a detour, and we're going to have to find the radius of the circle. Let's say maybe this would be like, let's say this is step 0. Step 0 is going to be to find the radius of the circle. And yeah, we're actually going to need this radius in order for us to complete steps 1 and 2. Now the question becomes, well, how are we going to find the radius? Fortunately, we can use triangle AOB to aid us here. This triangle here. Now what we know is that, yeah, this is a right triangle, and there's a very special formula that we can use that helps us find the lengths of sides of right triangles. Now side lengths OA and OB are both radius of the circle. So let's say that the radius is r. This is r. This is length r, and this is length r. We can use the Pythagorean theorem to relate lengths of these sides to the hypotenuse. I'm going to write down here, use Pythagorean theorem. And if you don't remember what the Pythagorean theorem is, that tells us that a squared plus b squared is equal to c squared. So we're going to use the Pythagorean theorem here in order to find the radius of the circle. Now there's a quicker way to do this that I'm going to discuss after we use the Pythagorean theorem, but I'm just going to use the Pythagorean theorem here because this is what most people can remember. Now we're just going to substitute. A and B are the length of the legs of the right triangle. In this case, both of those legs have a length r. So I'm just going to substitute r for A and r for B. And when we do that, we get r squared plus r squared is equal to c squared. C is the length of the hypotenuse. And the hypotenuse is the length 6 square root of 2. We're just going to substitute 6 square root of 2 for c. So we have r squared plus r squared is equal to 6 square root of 2 squared. On the left side, r squared plus r squared is going to simplify to 2r squared. And then 6 square root of 2 squared. This is the same as 6 squared times the square root of 2 squared. 6 squared is 36. Square root of 2 squared is 2. And then by dividing both sides by 2, you cancel. And cancel. We get r squared is equal to 36. Or that r is equal to 6. Now, technically, this equation right here does have two solutions. R is equal to 6 and R is equal to negative 6. But in the context of our problem, R is equal to negative 6 doesn't make any sense. You can't have a negative radius. So only the positive solution is valid here. Yeah, you could use the Pythagorean theorem to find this radius. But you could also recognize that we have a special right triangle in this case. What we have here is a 45, 45, 90 triangle. And we know we have that because both of the legs have the same length. So when you have a 45, 45, 90 triangle, that tells you that these two angles here are 45 degrees. I'm just going to go over this quickly. And it also tells you that the length of the legs of this right triangle are going to be equal to the length of the hypotenuse divided by the square root of 2. The hypotenuse is a 6 square root of 2. So in order to find the leg, knowing that we have that special right triangle, we just take 6 square root of 2 divided by 2, and we get the radius is equal to 6. Again, I'm not going to go over this in detail, but I'll just right here use property of 45, 45, 90 triangle. Okay. This is all step 0. And that concludes this step 0. And I know that seemed like a lot of work, but the nice thing is that now step 1 is pretty straightforward, right? Now we're just going to substitute r is equal to 6 into this equation here, this formula. Okay, oops, I don't want that. I'll say the area of the quarter circle is 1 over 4 pi r 6 squared. 6 squared is the same as 6 times 6 or 36. So this is 1 over 4 pi times 36. And then we can simplify this by doing 36 times 1/4, which is the same as 36 divided by 4, which is 9 pi. So 9 pi is the area of the quarter circle. The second step, now that we finished step 1, is to find the area of triangle AOB. And the area of a triangle is area of triangle is 1/2 base times height. In our case, the base and height are both r, which means that area triangle, I'll use, oops, I want to do A, I'm going to use, just put TRI here to represent triangle to not confuse it with this. Let's say, I'll do QU to represent quarter circle. This is going to be equal to 1/2 times 6 times 6. The base and height of the triangle are both 6, which is going to be 1/2 times 36. And 1/2 times 36 is 18. Okay, now something else you may have noticed here is that we could have just directly used r squared is equal to 36 down here and substituted that into this equation and this equation, which is also a little bit of a shortcut, but just solving for r and making these substitutions is valid as well. Now that we finished steps 1 and 2, we can move on to step 3, which is subtracting the area of triangle AOB from the area of the quarter circle. And we're just going to combine our answers, or use the answers from both steps 1 and 2 to find the area of the shaded region. I would say I'm going to write ASH to represent this area, the area of the shaded region. That's going to be the area of the quarter circle minus the area of the triangle, which is 9 pi minus 18. So our answer in this case is going to be D. And that's all. Again, this problem was just a bit trickier than the one we were looking at before, but it's all about being able to use the information, give it in a problem, separate it, and just try to tackle the smaller steps in order to get to the desired answer. Thank you so much for watching. I hope you learned something from this video, and if you have not already subscribed, please do so. I have a lot of cool content coming on this channel, and I will talk to you in the next video. Bye.